The James Webb Space Telescope, JWST, has made a thrilling discovery. It detected beams of light resembling those from a bustling city, coming from just 4 light-years away. This astonishing observation has reignited the age-old question, are we alone in the universe? The telescope focused on Proxima Centauri b, the closest known exoplanet to Earth, and picked up unusual flashes of light that seem artificial. Could they be signs of alien life? Scientists are intrigued, and investigations are ongoing. Human fascination with extraterrestrial life is nothing new, but this discovery feels different. For once, we might have real evidence. During its observations, JWST detected light patterns on the planet's dark side, patterns that remarkably resemble urban light seen from space on Earth. This has set the scientific community abuzz. If these lights are artificial, they could be the clearest sign yet of intelligent life. David Kipping, an astronomer at Columbia University, explains that Proxima Centauri b is no ordinary rocky planet. Unlike typical planets that simply absorb sunlight and emit infrared radiation, this one behaves oddly, likely due to its unique relationship with its host star, Proxima Centauri. These quirks are what drew JWST's attention in the first place. The James Webb Telescope's power lies in its ability to detect infrared light, making it ideal for studying planets even during their nighttime cycles. While other telescopes struggle with faint signals, JWST excels at picking up subtle clues, such as potential artificial lights, on the shadowy side of exoplanets. Proxima Centauri b is in a tight gravitational dance with its star, receiving intense radiation and experiencing dramatic temperature swings. If it lacks an atmosphere, one side would be scorching hot while the other freezes, creating the kind of thermal contrast that astronomers are now studying to infer whether it has an atmosphere at all. JWST's observations offer more than just a light show. They provide vital clues about the atmospheric makeup of the planet. Finding gases like oxygen, methane, or water vapor will be monumental, as these are considered strong biosignatures. While JWST isn't optimized for detecting free oxygen, it can still spot related compounds like ozone, offering alternative evidence of life-supporting environments. Despite its brilliance, JWST is limited to studying nearby planetary systems. To dig deeper, astronomers are looking forward to the next generation of tools, like the Extremely Large Telescope, ELT, expected to be operational by 2028. The ELT will allow even more detailed readings of exoplanet atmospheres. Looking ahead, future space telescopes will feature advanced technologies that block out starlight, like coronagraphs and star shades, to better isolate light from distant planets. These tools are like putting your hand up to block the sun, helping telescopes clearly detect faint planetary light without the star's glare. A coronagraph is built into the telescope and dims the starlight internally. A star shade, on the other hand, is a massive, flower-shaped spacecraft that flies in tandem with the telescope and blocks the starlight before it even enters the lens. Both could revolutionize how we study planets and potentially identify signs of life. These innovations require extreme precision, minimal energy use, and the ability to function in space. But the payoff could be enormous. By analyzing a planet's light in detail, scientists could identify elements and even create surface maps or track alien weather patterns. The JWST's recent discovery is just the beginning. As it continues to scan the skies, it ushers in a new era of exploration, one where we may finally answer one of humanity's greatest questions. Are we alone? With every new observation, we inch closer to understanding our place in the universe. And if the city-like lights on Proxima Centauri b are what they seem, this could be one of the most significant discoveries in human history. The James Webb Space Telescope, JWST, is uniquely equipped to detect infrared light, which allows it to observe planetary activity even on the night side of distant worlds. Most telescopes struggle to pick up such faint signals from far away, but Webb excels at detecting even the tiniest traces of light. This makes it the ideal tool for investigating whether the mysterious lights on the dark side of Proxima Centauri could actually be artificial. Webb is especially good at identifying artificial light within specific wavelengths that differ from the broader light spectrum emitted by stars. Proxima Centauri b has a dynamic and intense relationship with its host star, which significantly affects the planet's environment. Like Earth, It experiences day and night cycles as it orbits its star. However, due to its composition and potentially thin or non-existent atmosphere, the planet likely undergoes extreme temperature swings, scorching hot during the day and freezing cold at night. These dramatic temperature variations offer valuable clues about the planet's atmosphere or lack thereof. Webb's infrared capabilities allow it to measure this heat and provide insight into whether Proxima Centauri has any atmospheric protection at all. Since the telescope orbits Earth in sync with the planet's orbital period every 11.2 Earth days, scientists can observe its daylight patterns in detail. If Proxima Centauri does have an atmosphere, the next step is to analyze its composition to determine whether it might support life. Key indicators like oxygen, water vapor, and methane could suggest biological activity. To find these, scientists must study starlight as it filters through the planet's atmosphere, a task that's scientifically challenging. Although Webb is excellent at detecting atmospheric components, such as water vapor, carbon dioxide, and methane, it's not as strong at identifying free oxygen, a major biosignature. Still, it can detect ozone, which also suggests a potentially life-supporting atmosphere. As researchers continue analyzing data from Webb, the broader quest to discover habitable exoplanets pushes forward. One limitation, however, is that Webb can only closely observe a handful of nearby exoplanets. To expand this search, astronomers are developing next-generation, ground-based telescopes like the Extremely Large Telescope, ELT, expected to be operational by 2028. Designed to observe exoplanet atmospheres in much greater detail, the ELT will provide sharper, more accurate insights into whether these distant worlds could support life. In parallel, space agencies are planning new telescopes with advanced technology designed to block out the overwhelming brightness of stars, making it easier to detect the faint light reflected by planets. This concept is similar to shielding your eyes from the sun to see more clearly. Two of the most promising innovations are coronagraphs and star shades. A coronagraph is a device built into telescopes that blocks starlight while allowing light from orbiting planets to pass through. By manipulating light waves, coronagraphs reduce a star's glare, revealing the dim glow of nearby exoplanets. A star shade, on the other hand, is a massive flower-shaped spacecraft that flies tens of thousands of kilometers in front of a telescope. It blocks starlight before it even reaches a telescope lens, letting only the planet's reflected light come through. Star shades are especially promising for studying planets in the habitable zone, the region where conditions might allow for liquid water and, potentially, life. Both technologies require incredible precision. For instance, a star shade must stay perfectly aligned with its telescope to within a tiny fraction of a millimeter across vast distances. They also have to be compact, energy efficient, and capable of withstanding the harsh conditions of space. Despite the challenges, the payoff could be enormous. If we can observe and analyze the atmospheres of exoplanets, we might detect biosignatures, chemical hints of life, such as oxygen, methane, or water vapor in specific ratios. These molecules, if found together, could point to biological processes at work on distant worlds. Astronomers are also exploring ways to capture more detailed images of exoplanets themselves. With each new advancement, we move one step closer to answering one of humanity's oldest and deepest questions. Are we alone in the universe? Advanced telescopes are now using cutting-edge adaptive optics to correct distortions caused by Earth's atmosphere and the telescope's own movements, delivering incredibly sharp images. With the help of starlight blocking technology, these instruments can not only detect exoplanets, but also map their surfaces and analyze their weather patterns. The next generation of space telescopes represents a giant leap in our quest to answer one of humanity's biggest questions. Are we alone in the universe? As our ability to observe distant planets improves, we're getting closer to uncovering the truth. Space exploration is advancing rapidly. With the James Webb Space Telescope, JWST, leading the way, we are entering a new era of cosmic discovery. Each new finding brings us a step closer to determining whether life exists beyond Earth. The recent observations of Proxima Centauri b, a planet orbiting the star closest to our solar system, could mark the beginning of a groundbreaking chapter in the search for alien life. Proxima Centauri has long been a focus of scientific interest, but the idea of detecting actual signs of life, like artificial lights or potential evidence of civilization, once seemed like science fiction. The fact that JWST may have spotted unusual light patterns on Proxima Centauri has sparked hope and excitement, both within the scientific community and among the public. For the first time, people are daring to believe that contact with intelligent extraterrestrial life might one day be possible. But JWST's mission goes far beyond spotting lights. It's also analyzing planetary atmospheres, searching for chemicals that could hint at biological processes. Detecting biosignatures like methane or carbon dioxide could provide strong evidence that a planet might support life. The possible discovery of artificial illumination on Proxima Centauri isn't just fascinating. It represents a turning point in how we explore the cosmos and search for signs of intelligence beyond Earth. For decades, humanity has looked to the stars, wondering if we are truly alone. Thanks to JWST's unparalleled sensitivity and precision, we're finally seeing clues that could move the idea of alien life from speculation to scientific reality. The possibility of detecting structured light patterns, resembling those from a technologically advanced civilization, transforms what was once the domain of science fiction into a real, testable scientific objective. Even if these light signals are ultimately explained by natural phenomena, the tools and technologies developed to detect them are propelling astronomy into a golden age. Instruments like the extremely large telescope JWST and future space observatories equipped with coronagraphs and star shades will further enhance our ability to study exoplanets, analyze their atmospheres, and identify life-related molecules with unprecedented accuracy. This growing level of detail brings us closer than ever to answering one of the most profound questions in human history. With every new data point, every improved method, and every refined instrument, the search for life becomes more focused and full of promise. Each breakthrough, no matter how small, helps build a clearer picture of a universe that might be more alive than we ever imagined. And even if direct contact with intelligent beings remains a distant dream, the very fact that we're capable of detecting potential signs of life across light years is a testament to human ingenuity and curiosity. Whether the lights observed on Proxima Centauri turn out to be evidence of an alien civilization or a rare natural phenomenon, the journey to find out will push the boundaries of science in ways we've yet to fully grasp. The universe is vast, but thanks to these incredible advances, it now feels just a little less lonely.